Welcome to Syeadh Academy. What is virtual memory, and how does it work in an operating system? Virtual memory is a memory management technique used by operating systems to provide the illusion of having more physical memory, RAM, than is actually available. It allows programs to execute as if they have access to a large, contiguous block of memory, even if the physical memory is limited or fragmented. In a computer system, the virtual memory space is divided into fixed-size blocks called pages. The physical memory is also divided into equal-sized blocks called page frames. The operating system manages the mapping between these virtual pages and physical page frames. When a program is executed, it is loaded into virtual memory. Initially, only a portion of the program necessary for execution, called a page, is loaded into a page frame in physical memory. The operating system keeps track of which pages of the program are in physical memory and which are not. If a program accesses a page that is currently not in physical memory, a page fault occurs. The operating system handles the page fault by selecting a page frame to evict from physical memory. If the evicted page has been modified, it is first written back to disk to preserve its state. Then, the required page is loaded from disk into the newly available page frame, and the program's execution continues as if the page was always in memory. This process of loading pages on demand and evicting pages to disk is transparent to the program. The program sees a large virtual memory space that it can use, and the operating system takes care of managing the physical memory resources efficiently. Virtual memory offers several benefits, including 1. Memory isolation. Each program operates in its own virtual memory space, preventing one program from accessing or modifying another program's memory. 2. Memory sharing. Multiple programs can share the same physical memory pages, which reduces memory usage and allows efficient communication between programs. 3. Simplified memory management. Virtual memory simplifies memory allocation and deallocation for programs, as they can assume they have access to a large amount of memory. 4. Swapping. Virtual memory allows the operating system to swap pages between physical memory and disk, enabling the system to run more programs than can fit entirely in physical memory. Conclusion. However, the use of virtual memory introduces performance overhead due to the need for page faults and disk input and output operations. Optimizations like caching and intelligent page replacement algorithms help mitigate these overheads and ensure efficient memory management.